The Washington State Residential Code, often referred to as WAC, mandates specific electrical requirements for electric water heaters. A crucial aspect of this code pertains to the minimum circuit amperage and wire gauge necessary for safely and effectively powering these appliances. Since the 2009 edition of the Washington State Residential Code, a minimum 30-amp circuit utilizing 10-gauge wire has been required for electric water heaters. This requirement ensures that the electrical infrastructure is capable of handling the load demanded by the water heater, preventing overheating and potential fire hazards. Understanding the rationale behind these requirements involves several key electrical concepts. Firstly, amperage refers to the amount of electrical current flowing through a circuit. Electric water heaters, due to their function of heating water, typically draw a significant amount of current. The 30-amp minimum ensures that the circuit breaker or fuse protecting the circuit is adequately rated to handle this current without tripping or blowing prematurely. Secondly, wire gauge is a measure of the wire's cross-sectional area, which directly affects its ability to carry current. Lower gauge numbers indicate thicker wires, which can carry more current without overheating. The use of 10-gauge wire, which is rated for at least 30 amps under typical residential wiring conditions, ensures that the wire can safely conduct the current demanded by the water heater. It is important to note that this requirement is not arbitrary, but is based on established electrical engineering principles and safety standards. The National Electrical Code, or NEC, serves as a foundational document for electrical codes across the United States, and many state and local codes, including the Washington State Residential Code, are based on or closely align with the NEC. The NEC provides guidelines for determining the appropriate wire size and overcurrent protection, such as circuit breakers or fuses, for various electrical loads. When installing or replacing an electric water heater, it is crucial to adhere to these code requirements. Failure to do so can result in several potential problems. Firstly, using a circuit with a lower amperage rating than required can lead to frequent tripping of the circuit breaker, interrupting the water heater's operation and potentially damaging the appliance. Secondly, using wire that is too small for the circuit's amperage can cause the wire to overheat, which can melt the insulation and create a fire hazard. Moreover, violating electrical codes can have legal and insurance implications. If a fire or other electrical incident occurs due to non-compliant wiring, insurance companies may deny coverage, and homeowners may face legal liability. Therefore, it is always advisable to consult with a qualified electrician to ensure that electrical work is performed safely and in accordance with all applicable codes. In addition to the minimum circuit amperage and wire gauge requirements, the Washington State Residential Code may also include other provisions related to electric water heater installations. These provisions may address issues such as grounding, bonding, and the placement of disconnect switches. Grounding refers to the process of connecting electrical equipment to the earth, providing a path for fault currents to flow in the event of an electrical short circuit. This helps to prevent electrical shock hazards and minimizes the risk of damage to equipment. Bonding refers to the process of connecting metallic parts of an electrical system together, ensuring that they are at the same electrical potential. This also helps to prevent electrical shock hazards and minimizes the risk of stray currents. A disconnect switch is a switch that can be used to energize the water heater for maintenance or repair purposes. The code may require a disconnect switch to be located within sight of the water heater or readily accessible. When working with electricity, safety should always be the top priority. Before performing any electrical work, it is essential to de-energize the circuit by turning off the circuit breaker at the electrical panel. It is also advisable to use appropriate personal protective equipment such as insulated gloves and safety glasses. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. The Washington State Residential Code is subject to periodic revisions and updates. It is important to stay informed about the latest version of the code and any amendments that may have been adopted by local jurisdictions. The Washington State Department of Labor and Industries is responsible for administering and enforcing the state's electrical codes. They provide information and resources to help homeowners and contractors understand and comply with the code requirements. In summary, the Washington State Residential Code requires a minimum 30-amp circuit and 10-gauge wire for electric water heaters, a requirement that has been in place since the 2009 edition of the code. This requirement is intended to ensure the safe and reliable operation of electric water heaters and to prevent electrical hazards. When installing or replacing an electric water heater, it is crucial to adhere to these code requirements and to consult with a qualified electrician if you have any questions or concerns. Remember that electrical codes are in place to protect people and property from electrical hazards. By following these codes, you can help to ensure the safety of your home and family. Furthermore, understanding the specific requirements for water heater circuits is just one aspect of a broader understanding of residential electrical systems. Residential electrical systems typically consist of a service entrance which brings power from the utility company to the home, a main electrical panel which distributes power to various circuits throughout the home, and a network of wiring, outlets, switches, and fixtures. Each of these components must be properly installed and maintained to ensure the safe and reliable operation of the electrical system. The service entrance typically includes a meter, which measures the amount of electricity consumed by the home, and a disconnect switch, which allows the entire electrical system to be de-energized. The main electrical panel contains circuit breakers or fuses, which protect individual circuits from overloads and short circuits. The wiring throughout the home must be of the appropriate gauge for the amperage of the circuit itself. Outlets and switches must be properly grounded and installed in accordance with code requirements. Fixtures must be properly wired and supported. Regular maintenance of the electrical system is essential to prevent problems and ensure safety. This includes checking circuit breakers and fuses, inspecting wiring and outlets, and replacing worn or damaged components. It is also important to be aware of potential electrical hazards such as overloaded circuits, frayed wiring, and wet locations. Overloaded circuits can occur when too many appliances are plugged into a single circuit, causing the circuit breaker to trip or the wiring to overheat. Frayed wiring can expose bare conductors, creating a shock hazard and a fire hazard. Wet locations, such as bathrooms and kitchens, require special precautions to prevent electrical shock hazards. Ground fault circuit interrupters, or GFCIs, are required in these locations to protect against electrical shock. GFCIs are devices that monitor the current flowing through a circuit and quickly interrupt the power if a ground fault is detected. A ground fault occurs when current flows through an unintended path, such as through a person's body. GFCIs can prevent serious injury or death from electrical shock. When performing any electrical work, it is essential to follow safe work practices. This includes de-energizing the circuit before working on it, using appropriate personal protective equipment, and following all applicable code requirements. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. Firstly, ensure the power is off. Secondly, test the circuit to verify power is off. Thirdly, use insulated tools. Fourthly, never work alone. Fifthly, inspect your work. And sixthly, if unsure, seek professional help. Electrical safety is paramount. Understanding the electrical system in your home, including the specific requirements for water heater circuits, is essential for ensuring the safety of your home and family. By following code requirements, performing regular maintenance, and practicing safe work habits, you can minimize the risk of electrical hazards and keep your home safe. Remember that electricity is a powerful force that can be dangerous if not handled properly. Always take precautions and consult with a qualified electrician if you have any questions or concerns. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work. The electrical codes are put in place to keep everyone safe.